In this lesson, we're going to take a peek under the covers as to how memory management works in C#. And this is important to know not only because it impacts your code, but also because questions around this topic are very common in job interviews. So we're going to talk about value versus reference types, specifically the stack and the heap. So we've already learned in this course that when your program's running, the data gets stored in memory. However, when I first introduced you to the topic, I was just using a single table to show you what was happening, because I just wanted you to see that data was being stored in variables and you could pull that data in and out. The truth is actually a little bit more complicated. C# programs use two regions of memory storage. The stack is an array of memory. It acts as a last in, first out, sometimes you hear that called LIFO, structure. The heap is organized into memory chunks. It can be accessed in any order. So the stack stores several types of data. It stores values of certain variables, specifically value types. It stores the program's current execution environment. It stores parameters passed into methods. The system handles all of the stack manipulation, so all we really need to know is to understand conceptually how it works. When you place an item onto a stack, it's called pushing. When you delete an item from the stack, it's called popping. And the way I like to visualize a stack is kind of like in a restaurant when you have those plate serving trays where you put the plates in, and as you put them in, it drops down, and as you take them off, it goes back up. That's kind of like the push and pop concept of a stack. The heap is chunks of memory space. It uses pointers to reference memory locations that are currently in use. .NET has something called the garbage collector. Periodically, the garbage collector is going to go through the heap, and it's going to scan all the memory that's being used. And if it discovers that something on the heap is not being referenced anymore, it's going to mark it for cleanup and then clean up your memory for you. This is actually a really big deal. Back in the old days, we used to have to remember to clean up after ourselves. If you forgot to do it, you would get a memory leak, and eventually your program would fill up all the memory and crash the computer. Value versus reference type determines where something is going to be stored, on the stack or the heap. A value type is stored on the stack. Common value types are like the primitive types, integers, decimals, doubles, etc. Reference types require two segments of memory storage. The actual data of a reference type is stored on the heap. However, on the stack is stored the memory address of the data. So the stack has a memory pointer to the location on the heap where the real data is. And I'm going to show you some illustrations of this. But first, we got to ask, why do we care? It's because when we assign reference types or pass them as parameters to methods, we aren't passing the real actual data. We're only passing a pointer to that data. So any changes you make to a reference type inside a method will affect all of the variables that are pointed to that data. But when we pass a value type, it makes a copy of the data. So any changes made inside do not impact the other values. Now here comes some code samples. Here we have an example of a value type. Int x equals 5. X is going to be stored on the stack. I've also created a method called changeValue, which takes in int x as a parameter and changes the value to 10. Now in my classes, I like to ask my students, what do you think the value of x will be in the main method when we print it? And it usually ends up about half and half. Half of them will say 10, half of them will say 5. The answer is 5 because x is a value type. When we declare int x equals 5, on the stack it's going to create a location for x in the main method and set the value to 5. Then we call the change value method. We pass the value of x in as a parameter. Now we have a second variable x inside the change value method. It gets set to 10 in the code. When the method ends, that x goes away, and the original x is the only one that remains. It's the only one in scope in main. So it will print 5. And you can type this into your IDE to check me. Reference types are usually classes and arrays. Here, I've created a class called point, which has an x-coordinate and a y-coordinate. In main, I'm going to declare a new point, and I'm going to call it P1. And I'm going to set the x-coordinate to 5 and the y-coordinate to 10. Then I'm going to declare another point variable, P2, and I'm going to assign it to P1. Then I'm going to create a point P3 and assign it to P2. Then I'm going to set P3's y-coordinate to 50, and after that I'm going to print out P2's y-coordinate. And again, what do you think is going to print? I get a lot of people that say 0 or 10, and they're both wrong. Because all of these variables have been assigned to P1's data location, it's going to print out 50, because when P3.y gets changed to 50, P2 and P1 are pointing to the same data, so they all get changed. This is what it looks like in memory. We declare P1. That goes on the stack. The actual point object gets declared on the heap. It gets set with an x of 5 and a y of 10. Then when we declare P2 and say that it's equal to P1, P2 and P3 go on the stack and they all point to the heap to the same object. Lastly, when we change P3.y to 50, they still all point to the same object, and y is now 50. So it will print 50. Another example of this. Here again we have a point P1. We set x to 10, y to 5. I've created a method called changePoint, and I pass it in P1 as a reference. In the method, we have a parameter called P. P is going to be assigned to the same memory location as P1. So unlike in our value example, we're going to see that once we create P1, when P comes into the picture, it's going to point at the same memory location. So any changes we make in this method, like setting x to 20 and y to 10, are going to impact P1 because it's the same object. So then when we go to print out x and y, when the method returns, the variable P goes away because the method is done, and P1 is the only one that remains. It's still pointed to the same object that was modified. So this will actually print out 20 and 10. The last thing I want to talk about is a keyword called ref. Ref can be used to force a value type to be treated like a reference type in a method. So if you look at this previous code, where x was 5 and then we changed it to 10, but it stayed 5 because it was a value type, look at my method here, change value, ref int x. That ref keyword means even though this is a value type, I would like you to treat it as a reference type. We have to put ref in the method and also in the call in main. And if you type this code into your IDE and run it, when it prints out the value of x, it will be 10.